Alright, hello again, this is Jeff Scott for the 152-143 Intro to Java Programming class for the Spring 2016 semester at Blackhawk Technical College. I've been hanging out with you, going over the PowerPoint presentations for our book, starting out with Java from Control Structures through Objects, 6th edition by Tony Gaddis. I've done the first 3 chapters. Chapter 1 was kind of an overall thing on computers and programming and a few other things. Chapter 2 was a kind of a primer or an introduction to Java. And Chapter 3 was on selection structures, where we talked about if else, if, and switch statements. In this chapter, as mentioned, we're going to go over loops and we're going to go over files. So we'll talk about first the increment and decrement operators. Then we'll talk about the while loop, the do while loop, the for loop, get into running totals and Sentinel values, talk about nested loops, which again is a loop within a loop, break and continue. We'll go through the author's advice as far as which loop to use at which time, and then we'll also get into an introduction into file I/O and talk a little bit about generating random numbers. All right, so and I've come up with an example for you, but what I'm going to do instead of that is I think I'm going to hit enter a couple times here. All right, I'm going to just quickly write something here. I'm going to say int x equals 23, all right, and int y. All right, so right now x is equal to 23 and y does not have a value. If I say this, y equals plus plus x, all right, what that means, all right, add 1 to x, assign result to y. So in other words, when we get done with this, this adds 1 to x, which means x will be 24. Then it takes that 24 and assigns it to y. On the other hand, if I do this, if I say y equals x plus plus, kind of at least, kind of, the opposite happens. In other words, you want to assign y to x, then add 1 to y. So in other words, when you get done with these two things, all right, here y equals 24 and x equals 24. All right, in this example that I just showed you. However, when I do it the other way, all right, when I do it this other way and I reverse it, so to speak, now y is equal to 23 and x is equal to 24. So this is called the pre-increment operator. It means do the incrementing by 1, then take the result and assign it. This is the post-incrementer. So this says assign, then go back and add 1. Plus plus, whether it's regardless of which side of the variable it's on, you can only be used to add 1 to a variable, either prefix, which is what this is called, or postfix, which is what this is called. Now, one thing about this, just so you see it, and you might have already guessed this, but there's also a minus minus. So this says not add 1, but subtract 1 from x, assign result to y, and this says assign y, I guess that was wrong to begin with, that was assign x to y, and then add 1 to x, sorry. So this said, yeah, so that was backwards. All right, so this says assign x to y, then subtract 1 from x. So in other words, once we do this, this says first subtract 1 from x. X was 23, so x is now 22. Then it says take what was in x, which is 22, and assign it to y. So y is also 22. This one says take what was in x and assign it to y. Well, if that was 23, then y is 23. Then subtract 1 from x. So x is 22. And I just wanted you to see that because this is called the pre-increment and pre-decrement, the post-increment and the post-decrement. All right? So I'll leave that up there for a second so you can hopefully see what's going on in there. And hopefully I didn't make any mistakes on it. So add 1 to x, assign to y, right? I believe everything that's in there is correct. All right? Why am I doing that? Because that's what they talk about at the beginning of the chapter here. The author talks about incrementing and decrementing, the plus plus and the minus minus. Okay? And they give some examples, differences between pre and postfix. So that's what I did. All right? All right. Let's talk about while loops. And I'm going to show you all 3 of the loops. So we'll talk while loop and look at an example. Then we'll talk do while loop and we'll look at an example. Then we'll talk for loop and we'll look at an example. I've provided the same example for all 3. All the example does, it's very simple, is it assigns 1 to a variable that we call LCV, which is loop control variable. And then it has that go from 1 to 10 and it prints out. So loop control variable equal 1, loop control variable equal 2, loop control variable equal 3, all the way to 10. All right? The reason that you use looping structures is you want to repeat 1 or more lines of code for a certain number of times. The while loop, as mentioned here, this is a Boolean condition. As long as that condition is true, you'll do what's in here. You get done, you come back up. If it's still true, you do it again. If it's still true, you do it again. Eventually, you probably want it to go false. If it never goes false, you have what's called an infinite loop. Sometimes you want that. Sometimes you want your code to run 24/7, 365, 24/7. So you might want an infinite loop. The while loop is known as a pretest loop, and I'll show you exactly what that means, but basically it means you make the test before you go into the loop body. All right? Again, if you don't have the loop become false someplace, you get an infinite loop. A while loop can execute 0 times, and it can execute an infinite number of times. All right, don't worry about that flow chart, not a big thing. Again, here's an example of an infinite loop. X equal 20. While x is greater than 0, print out x is greater than 0, but you're never changing the value of x. So it checks it, it's still 20, it's still 20, it's still 20. This is going to print out x is greater than 0 forever. But if you added an x minus minus after that system.out.println line, that would fix it. You wouldn't have an infinite loop any longer. Here, is the way that you'd want it to go. Okay? All right. If you're going to have multiple lines in a loop, you must put them within curly braces. I always use curly braces anyway, even if it's just 1 line. So let's look at this example right here. All right? Input validation is the process of ensuring that input is valid. So you're telling the user to enter a number between 1 and 100. And then you say while the number is less than 1 or the number is greater than 100. So that means that if the number is 0 or less, 101 or greater, you tell them it was invalid and you ask them to do it again. All right, so you're starting to learn the process of input validation. So the example that I put in here, here's the first one. Again, LCV just means loop control variable. I set it equal to 1. While it's less than or equal to 10, I print out LCV equal with its current value, then I add 1 to it. Now I'll leave this here for a second, but this, the way it is right now, is correct. It's going to print out LCV equals 1, LCV equals 2, all the way through LCV equal 10, then it'll get out of the loop. Now I mentioned that this is called a pretest loop, and if you look up on top here, If I change this to 11, well, 11's not less than or equal to 10. So if this were to be 11 to start, this would be false initially, so it would fall out and it would never print anything. That's what they mean by a pretest. So again, this is the first example of writing a loop in Java. That's exactly how you write it, and I'm showing you the output, etc. Now I'm going to show you two more examples, one that uses a do while in just a minute, and then the next one which will use a for. All right, but they will all work in a similar way, but they will all result in the same output. In other words, every one of them will end up printing out this. Okay? All right. So, where the while loop, we already mentioned, is a pretest loop, which means you test it at the top of the loop before you go into the loop body. A do while is a post-test loop, which means that you must execute the loop at least one time because you don't check it until the bottom of the loop. All right? This is the only time when you use any kind of if or switch or whatever that you must put a semicolon at the end here. That's not an error. All right? So let's take a look before we go into the for loop. Let's take a look here. You already saw this one. This was the one we just looked at. This was our while loop. So let's look at the second example, which is the same thing but done with a do while loop. All right? Again, here we're initializing our loop control variable. Here we're testing it, but since we test it at the bottom, it's going to print out the same thing. But if this was 11, now it would print out LCV equals 11. It would add 1 to it, meaning it's 12. It would say, is it less than or equal to 10? It's not, so it would fall out. So you always go through it. These two examples also show you everything that you must do in a looping construct. Number one, you must initialize your loop control variable. So that's what we're doing there. Number two, you must test your loop control variable. And finally, number three, you must change your loop control variable value. All right, so initialize the loop control variable, test the loop control variable, change the loop control variable. That's the first one. The second one looks very similar in that, what are we doing? Right here, initialize your loop control variable. That's what we're doing there. We're testing the loop control variable right here, and we are changing the loop control variable value right there. So again, with this one, as mentioned, you check at the bottom of the loop. It is a post-test loop, where previously what we saw was a pre-test loop. All right, and that's kind of mentioned here too. Again, the do while loop is a post-test loop, meaning it will execute prior to testing the conditions. So you always go through it at least one time. The last loop is also a pre-test loop, so you check it at the beginning, and it's called a for loop. The for loop is also called a counting loop because you need to know exactly how many times you're going through it. So with that last example, notice here we had one line of code, 2, 3, 4, 5, 6 lines of code for the while loop. We've got 1, 2, 3, 4, 5, 6 lines of code for the do while loop. And we have 1, 2, 3, 4 lines of code for the for loop. So a lot of developers like to use the for loop because you end up writing less code. But notice what we're doing in here, right there. That's initializing our loop control variable. Right there. That's testing our loop control variable. Right there. That's changing the value of our loop control variable. So what we did previously in 3 lines, we're now doing in 1 line. All right? Previously, we did this outside of the loop. Then we tested this in the while or the do while. Then inside of the loop, we did this. Now we're doing all that stuff on the outside of the loop. But it's a pretest loop, so again, if we set that equal to 11, we'd never go through the loop even 1 time. All right? So as the author mentions right here, it's pretest. It allows the programmer to initialize the control variable test and modify all in 1 line of code. As it says, just so you know, any part that's in a for loop, you can leave it out. And I do want to mention something to you, just so you see this. Okay? If I were to print where we have here, this while and all the other stuff, if I were to print this, while 1, that sets up, that's an infinite loop condition. Because 1 is always 1. It's always true. If I say down here, if I were to have said down here, do while 1, that will also be an infinite loop condition. Finally, on the for loop, if I do this, for, and I put nothing in there but 2 semicolons, that will be an infinite loop condition. So if I do want to set up an infinite loop, those are ways in which I can do it. Not only that, just so you know, in a for loop, I can leave any of these things out. So in other words, if I did up here, if I went int, oops, sorry. If I went up here and I said int, come on. If I typed up here, int LCV equal 1, well, I don't have to do it again, so I can just leave it blank. That's totally legit. So why would I want to do that instead of doing this? All right? Why wouldn't I want to do it this way? If I do it like this, I'm declaring that variable inside of, basically it's only known inside of the loop. So once I jump out of the loop and I get out of it, that's not known anymore. But if I do it like this, since I'm declaring that variable outside of the loop, I can use it, all right, I can end up using it out, since I'm declaring it outside of the loop, I can use it outside of the loop. All right. I think that basically everything that's in here, I've been going over it with you. So the author gives several examples, okay, and then talks about running totals. Well, let's talk about a running total. Let's take a look at one of these. All right. So I'm going to go back to the example that I had right here, and we'll look at just the for loop example. All right. So I'll go back to the way this was set up, but I'm going to have a new variable in here that I'm going to call total, and I'm going to set that equal to 0. All right. So now what I want to do is I want to print out LCV equals 1, LCV equals 2, but I want to say in here total plus equals LCV. All right. Then once I fall out of the loop, I want to do a system.out.print line here where I say total equals, and I put total. Think about play computer. All right. This is the same thing in here. What this is going to do is it's going to go through this 10 times. This is going to say 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. And if you add all those up, what this is going to print out over here is total equals 55. Now total right there, this is known as an accumulator. It's accumulating a value. This is a loop counter. This is a counter. All it's doing is it's counting the number of iterations I want to go through. This is an accumulator because I'm actually figuring out something as I go through here. All right. There's also something that's called a Sentinel value. Well, a Sentinel is based off of the old, if you remember that if you had somebody guarding something, they would say, halt, who goes there? That was the Sentinel. But a Sentinel value is a stop value that you use in a program. So let's suppose I was reading in a number of grades, all right? And the grades, if the person didn't take the test or failed and didn't answer anything, they'd get a 0. If the person got everything on a test correct, they'd get 100. So my valid values, there's 101 of them, 0 through 100. So I could take a Sentinel value and say, I tell you to keep entering test scores. But then I could say, until you enter a score of -999, that would be my Sentinel value. That would say, stop putting in input. All right? So that's a regular Sentinel value like that. At the end of the chapter here, they'll talk a little bit about files. And files usually have a thing at the end of a file that's called an EOF marker that says that you're done. Okay? All right. A nested loop is a loop within a loop. So the idea is this is going to be 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 0, 8, 0, 9, 1, 0, 1, 1, 1, 2, etc. They've got an excellent example in the book, this clock.java, which we'll talk about in more coverage in just a bit. All right, next are break and continue. All right, so let's take a look at both those. So let's go back to our example that we were just looking at in here. Okay, now I don't care about this Sentinel value anymore, so I'm just going to get, the accumulator, so I'm going to get rid of it because I just showed that to you. All right, so if I come through here and I type if x equals 6, break. Break means get the heck out of the loop. So now our output is going to be 1, 2, 3, 4, 5, and that's it. Because once it reached 6, we said if it equals 6, break. We have to print out 6 too, because we've got the print statement beforehand. So this would print out LCV equals 6, then it would get out. Well, let's say we do this. Let's say that we put in the word here, continue. All right. Then what's going to happen, continue says skip the current iteration. In fact, I'd have to put, in this case, I'd have to put the system.out.println there. So this would say 1, 2, 3, 4, 5. Now it's 6. So that would say continue, which says skip the rest of the loop and go back up to the top. So this would print out 1, 2, 3, 4, 5, 7. This would, in essence, skip. So when you do a break, as it says right here on the slide, it can be used to abnormally terminate a loop. All right, it's considered bad form to do it, but sometimes you have to for whatever reason. Continue, all right, which is another one that really isn't recommended that you use, causes the current loop iteration to terminate and the next iteration to begin. So, which loop should you use? Well, as it says, the while loop and for loop are pretest loops. right? You want to use a while when you don't want the statements to execute if it's false to begin with. You use a for if you're doing some kind of a counting loop. You use a do while if you want to make sure that your code executes at least once. Quite often what I'll do is when I've got error code that I want to make sure runs so I can test it, I'll put it in a do while loop. And then once I've checked it and it looks the way it's supposed to, then I'll change it back to a while loop. All right. The last part of the chapter in here discusses file input and output. So what they're talking about doing is when you run a program, all the programs we've looked at so far, every program you get output, but as soon as you stop the program run, the output's gone. If you want to permanently save your output, you can use files. As it says there, generally there's two types of files, binary files and text files. If you can read the file in an editor like Notepad or Notepad++, it's a text file. If you cannot, if it looks like strange symbols or circles or whatever, it's binary text. So as mentioned here, if you want to open up a file for text output, you use what's called the PrintWriter class. So notice PrintWriter, that's a class, that's the object, output file, equals new PrintWriter student data.txt. And what that'll do is that's going to cause a new file to be created called student data.txt. If the file previously existed, all of its contents will be erased and it'll be replaced with this new file. So PrintWriter, as mentioned here, allows you to write data to a file using print and println, as we've been doing in the past. All right, so this would write to the file called names.txt. It would say Chris on one line, Catherine on the next line, and Jean on the next line. Then you'd close the file. If you want to be able to use PrintWriter, you have to import java.io, which stands for input output, .star. Now, since you have to do that, it's possible that you'd be trying to either write to a file or read from a file, and maybe you didn't have permissions to do that, or something went wrong. So what can happen when you work with files is something that's called an exception can be thrown. And an exception is something that's an exception to the norm. It's not a good thing. I've told people before, if you're walking down the street and you're pushing a stroller and you've got a baby in it and somebody walks by and says, "Oh my, what an exceptional child," you'd probably say thank you, because it probably at least is meant to be a compliment. On the other hand, if you get an exception in a programming language, it's an exception to the norm. It's not a good thing. So as it says, the method that is executing the exception is thrown, when the exception is thrown, must either handle the exception or pass it up the line. And if it doesn't handle it, eventually the program will abort. All right? So it says if you want to pass it up the line, which is what they talk about now, I think it's chapter 11 that they'll talk about handling the exception. But for now, you use what's called the throws clause. And just so you're aware of this, you as a developer, you can throw an exception without an S on it. But if you have the word throws, that means Java did it. So throw, you did it. Throws, Java did it. All right? So what this says is it's possible, not that it's going to happen, but it's possible, since you're working with files in this program, it could throw, Java could throws an input-output exception. So you have to put that in there so the system knows that it's possible. Not necessarily that it's going to happen, but that it could possibly happen. All right, earlier we saw when you were opening up that file and it said, geez, it removed everything that was there, but what if you want to just add to a file? Then when you open it up, you put true on the end, which means open it up in what's called append mode. So if the file exists, go to the end of it and start adding new material to it. All right. It says there on a Windows computer, paths contain backslash characters. Okay, so if you want to be able to put that in there, you need backslash, which will escape So this will mean a:\\. All right? But Java allows you to put things this way too. If this gets confusing to use the two backslashes, you can use forward slashes instead. All right. Well, we just talked a little bit about writing data to a file. What about reading data from a file? Well, notice file equals new file, and then we do a scanner. So we're reading it from that file, but previously we used keyboard right here. Now we're using my file from right there. All right, totally legit. Not only that, it's possible for you to write a program that opens the same file for reading, let's say for writing, write to it, close the file, open it up again for reading, close it, and then, again, you can do that as many times as you want to or need to. So this example right here on the screen says, create a new keyboard object, and then on the keyboard, this would actually occur right on your console. It would say enter the file name. You'd put a file name in there, and then it would take this input file and associate it with that new file name you put in. And that's pretty much what they say in here. All right. So here's reading from a file. And just like we saw previously, when we were trying to write to a file, when you try to read from a file, it can throw an exception. Why? What does that mean? Why would you throw an exception? Well, it's possible that you didn't have permissions to read from that file or write to that file, or maybe the disk that you were using was full, or whatever, or you put a wrong path in. There's a lot of things that could conceivably happen. All right. This right here talks about how the scanner has a has-next method. This is also called a PEEK, P-E-E-K method, because it looks at the next record and it says as long as there's something there, keep going. But when it finds an end of file marker, stop. All right, in the last 2 or 3 slides that are in this chapter, what the author talks about in here is they said some applications use random numbers. You will use one, all right? You will create a game, a simple game with random numbers. When you want to do that in here, you have to import from the Java util class the random class, all right? Actually, this is the util package, and it's the random class. So you import java.util.random. It must be a capital R, and then you can say random, give it a name, equals new random. So that'll create a new random number for you. We'll talk about this in more depth and breadth of detail in class. Notice you can use next int, all right, next float, and next double, and that's pretty much it.